Hello, everyone. My name is Kanushri Tori, and I'm delighted to welcome you all today. Let me quickly introduce you to Let's Unbound. Well, Let's Unbound is a global platform that empowers students like you to build strong foundations in STEM, life skills, and college readiness. We are on a mission to help learners in 25 plus countries achieve their dreams by the age of 35 through personalized learning and dedicated mentorship. Our programs cover skill development, gifted test prep, college preparation, and even Ivy League readiness. Here's a quick snapshot of our journey so far. 4,000 plus students taught, 125,000 hours of teaching sessions, a presence across 25 plus countries, and a global rating of 4.9 out of 5. Now, I'm excited to hand it over to your mentor for today, Rishabh, who will be guiding you through the SAT Math Masterclass. Over to you, Rishabh.
Hello, everyone. This is Rishabh Malik, and I'll be taking up the SAT Masterclass today. Just a small introduction about me first. I've been tutoring for the 6 years now. I take up the AP curriculums, the IBDP, IGCS, calculus, both ABBC, as well as my expertise lies in the SAT maths part. Let us start directly exam pattern first, and then we'll directly jump into some topics, some questions that we frequently see, and we see that the students struggle with those usually. So I'll be sharing my screen now. Okay, so first let's try to understand what's the paper pattern, how many questions are there, what kind of sections are there in the SAT exam. So SAT is basically divided into two parts. We're going to have reading and writing section that covers the English portion and the maths portion. In each module, we are going to have 27 questions for English, 2 minutes each for each module there. Coming to the maths portion, we're having 2 modules again, 35 minutes each, 22 questions. Previously, what used to happen was that it was conducted both in offline as well as in online. Section in which calculator could be used, the other one calculator could not be used, a GDC, graphing display calculator. But now they've common for both modules. You can use a GDC there. You can use Desmos there. Desmos is also embedded in the Blue Book app. It's now fully digital. In no country, you don't take any pen and paper SAT. Everything is digitized. Coming to the breakup of these 22 questions that are given here in the maths part. These 22 questions are divided as 20 plus 2, where you get marks out of 20 questions. But these 2 questions here are research questions. These are randomly placed somewhere. You will not know if it's the first one, last one, somewhere in the middle. You'll not get any marks for that. These are just placed to see some do some internal research, and we do not have to put any extra efforts or something about it. Our aim is to get as many marks as possible. This is a standardized test. It will have some easy level questions, some slightly challenging ones, then some good level of application-based questions. As well as we have adaptive nature of this test module-wise. If you're able to perform well in module 1, you will get a tougher module 2. That module 2 will be having slightly more challenging questions, and your good score increases there. If you get a module 2, that's tougher. If it goes the other way, then the score would not be that much good. Now, moving forward. So the types of questions that we get there. In English, you will purely have MCQ questions, 100%. In maths part, there are 2 types. The MCQ questions, you have 4 choices. You have to just choose the best one out of that. And the second one is the SPR problems, student produced responses. There's a box provided there. In that box, you have to type the answer. There are certain rules that you need to follow. The very basic one is if you're having a positive answer, then maximum 5 characters are allowed. For example, if you get 2.36891 as the answer in your calculator or while solving it, then your answer should be 2.368, where we're counting the decimal as well as a character. You can also round off the last term. It's totally your call if nothing is told about it. If they're specifically mentioning you have to take up to 2 decimal points, or you have to take up to you have to round it off to a certain value, that has to be followed. If nothing's mentioned, rounding off is student's choice. Then we have, if we have the negative answer, in that case, a total of 6 characters are allowed, including a decimal and including the negative sign, following all the other processes as the same. I hope the paper pattern and everything is clear. If you have any questions, please feel free to put those in chat box. We'll be taking the question. Okay, now let's move forward and see some application-based questions that I was talking about. Some challenging questions that students usually face difficulty in. Okay, first question here is to find the equivalent form of the following expression. Now we can see that we're having a cubic polynomial on the top, and then we are having a linear expression at the bottom. So whenever we're having such a question, this is usually linked with the concept of remainder theorem. Let's try to decode that. See, if I'm having let's say a number 7 and I want to divide that with 3. So that goes like 3 times 2 becomes 6 minus 1. So I can now represent this entire division as 7 equals 3 times 2 plus 1. Or in general, if I generalize all these terms, I'll be having the dividend equals the quotient value times divisor plus remainder. This is the Euclidean division lemma that we use. If I'm having this fx over x minus a kind of a thing, so fx is my dividend and x minus a is my divisor. Now, if I divide this entire equation with the divisor, so I'll be having something like dividend over divisor equals quotient plus remainder over divisor. Because for the second term here, divisor cancels out. So this is the form in which we have to answer these questions. Let me just clear the board. I'll write down everything on the top. So if I'm having fx over x minus a, that can be written as the quotient value plus remainder divided by x minus a cap. Now, the best way to approach these kind of problems is by using the remainder. Because I can also see in the options, I'm having all the different remainders. Like in the first one, I can write this as 0 over x minus 2. Second one is already 1 by x minus 2, 3 by x minus 2, 2 by x minus 2. So this remainder value is all we have to figure out so that I can answer this question. And to find that, I can always use the remainder theorem. Let me just directly state that, then I'll be using it here. So remainder theorem says that if I'm dividing f of x by x minus a, then the value of remainder here would be given by f of a. Now, what is this a? It's the value of x here that makes this divisor 0. Like in this case, it will be x equals 0. That gives us x equals to 0. So my remainder value would be given by f of 3. What is this f? F in the initial part, that it's a dividend. So this entire polynomial is my f. So all I need to do to find the remainder is this is f of 2, my bad. So all I need to do here is I need to plug in this value 2 in the function of the polynomial that's given to me at the top in the numerator, and whatever answer I have, that will be my remainder. Check that with my options. So if I plug in 2 here, 2 cube minus 2 times of 2 square minus 2 plus 5. So this will give me 8 minus 2 plus 5. The answer comes out as 3. Remainder is coming out as a 3. If 3 is my remainder, I just need to check which option is having 3, and I can clearly see its options. I was explaining all this concept here, that's why it took a little longer, but it is way, way more time efficient than uh, the long division method that usually is taught to solve this question. Remainder theorem is applied in all these kind of questions whenever we are having fx divided by a linear, you can say, expression. So that was first question. Let's move to the next one. Yes, another application of remainder comes into picture here. There's a sister theorem for remainder theorem that's called factor theorem. Many of you might have heard about it. See, we say if I want to find the remainder value, then remainder is given by f of a. But what if the value of f of a comes out as 0? That means my remainder becomes 0. So if remainder is becoming 0, that means I'm going to have my factor there. Like if I divide 8 by 4, I get remainder 0. So 8 is a factor of, sorry, 4 is a factor of 8. So similarly here, when I'm dividing f of x by x minus a, and the value of f of a comes out as 0, we say that the value of x minus a is a factor. Okay. Now how to use that here? I can see that it's becoming, the function's becoming 0 at -1, at 1, and at 3. So I can say here f of -1 equals 0, f of 1 equals 0, and f of 3 equals 0. So from these three pointers, the three information pointers that I've fetched from the graph, I can directly say that x minus minus 1 is a factor, then x minus 1 is a factor, x minus 3 is a factor. So from here, x plus 1, x minus 1, and x minus 3. So look for the option which is having all these three as the factors. First of all, I can eliminate the first one where I'm having x plus 3, that goes away, x plus 3 gone again. Now, if you observe in the last two, they're all having these factors. The only difference is of the power zero. I can see x minus 3 is linear in the first one, x minus 3 is quadratic in the second one. That is having the power as 2. So to avoid that confusion, we observe this feature. I can see that the graph here is touching and going back. It's not crossing the x-axis. So whenever a graph touches a point and goes back at that particular point, the factor that we get, like x minus a in this case, raised to the power of m, this m value should be even. Similar is the case with 3. X minus 3 to the power of n, whatever we have, should also be even. So in this case, here we have 3 that should have an even power, and option D is giving us that answer. X minus 3 to the power of 2. So option D is the correct answer. We do not need to create any equation, do not need to satisfy any points. Also, we do not need to show all these steps. We just need to observe these pointers one by one. What are the factors? What are the roots first? What is the relationship between the roots and the factors? And using those factors, how do I check which one's going to be the even powered factor, which one's going to be the odd powered factor? If I have an even powered factor, I'll eliminate the ones which are having the odd number in the power. And by using that elimination, we'll reach option D. I hope that's clear to everybody. Okay, so let's move to the next question now. Okay, this is a very basic question, but I see most of the students making mistakes of it. So a store offers sale on t-shirts. The first t-shirt bought cost $10, but each additional cost $10. Each additional costs $5. If Lana buys X shirts, which of the following equations models the total cost of the shirts? The students always see this cost as 10 and consider that as the y-intercept because that's a constant that we're adding here. So that is not the case here. There are two approaches to solve this question. First one is by plugging in. I can plug in some random value, no, not the random, my bad. We'll plug in some value of x over here and the value cost here to analyze which option can give me the correct answer. Or I can also frame the equation. For one shot, the price is 10. So my point is 1, comma 10. I'll plug in one by one in each of these, see which one is giving me 10 is the answer when I plug in x as 1. Or if I have to create the equation, then we can see it in this way. Like if I start buying t-shirts, and let's say this is 0 t-shirts, this is x t-shirts. The first ones bought for $10. And the remaining ones that are left now are x minus 1 in number. One separate out of x, now we're left with x minus 1. So these x minus 1s are going to be charged with the $5 now. So each of them is costing 5. So my total cost here would be 10 times 1. That's for the first shirt. Then we have x minus 1 multiplied with 5. So if I simplify that, it's going to be 10 plus 5x minus 5. That results in 5x plus 5 is the answer. So reading the points, reading the options carefully is the key here. So option D is going to be my answer. Most of the students here mark the option as option A, where they take 10 as the constant value and say this is the y-intercept. But that's not the case here. Okay, now moving to the next question. Okay, these kind of problems, we can usually do it by using the cross multiplication and simplifying the steps. But I usually do not follow that. I ask my students to use Desmos in this. Desmos is a very powerful tool that we can use to visualize, to solve equations, to check the points of intersection, to do regression. If I know the points, if I want to find, if I need to find out the equation using the points, then I can use that. Yeah. So okay, so I can put this expression here in the first line in Desmos, and then this one in the second line in Desmos. But there's one problem here. Whenever we put something in Desmos in terms of alphabets, it only takes variable x and y. Rest all the other values are taken as constants. So this p will also be considered as a constant here. So what we do is we flip these values and say this is my x and this is x. So my equation would now become 5 times of x minus 1 plus 6 over 8. And the second part is 7 minus 3 minus 2 times of x over 2. So let's see how we can solve this on Desmos. Just a second. Okay, here. So I'll plug in these values here in this calculator. And actually this is given in the College Board app itself. There's a button on the top right. Whenever you're giving the test, click on this, the same window appears there. So it's going to be 5 times of x minus 1 plus 6. I'll put this in a whole bracket over 8. So I can see the plot here for the first one. Then when I plot it in the second one, I'll have 7 minus brackets 3 minus 2x and divided by 12. Now I want these two should be equal. When these are equal, that means they'll be passing through the same common point. So on Desmos, I just need to find that. So that is this point here. And our question was asking for the value of p. That means I need to look for the value of x now because we replaced our p with x. So our answer here in this case is 0.4545. We also need to keep in mind when we're putting the answers in the SPR question, we need to follow those rules that I told in the starting. So my answer then in this case would be, just a second. Yeah, here. So P was coming out as 0.4545. So that's how we can solve any complex equation without even picking up a pen. Moving forward to another question. So this accomplished figure given to us, and they're asking something about triangle PQR. They're saying that these two lines, line M and line L, are perpendicular, and they're intersecting at the point 2, 6. We have to find the area of the triangle PQR. To find the area, I need two things: the base and the height. And to find the base value, I need the coordinates of this point Q. Height is already given because that's 6 here. I can directly check the height of the triangle here. So height we are sorted with, that's 6. To find this Q, I need to use the relationship between line M and L, whatever is given to me. Like in this case, they're saying that these lines are perpendicular. I can figure out the slope of this first line, use that to figure out the slope of line M. If I'm having two perpendicular lines and I take slope of line 1 and multiply with the slope of line 2, that is equals to -1. So I'll do the same thing here. I'll be finding out the slope of line L. So that's given by y2 minus m is equals to y2 minus 5 1 over x2 minus x1. So 6 minus 0, that's y2 minus y1 over 2 minus minus. So that comes out as 6 over 6, that is equals to 4. It's a positive slope because as the line is going up. Now, if I plug in that here, 1 times slope of line 2 equals -1, so slope of line 2 comes out as -1. Also, this point here, this point Q here is specifically placed on the x-axis. So it will be of the type x comma 0, because height is 0 at the x-axis. I can use the slope value here to relate these 2 points. Again, applying the same thing, y2 minus y1 over x2 minus x1 equals -1 in this case. So 0 minus 6 over x minus 2 equals -1. So -6 over x minus 2 equals -1. When I cross multiply here, it will be -6 equals -x plus 2. If I solve for the value of x here, x would come out as 8. So this point is 8, 0. So this is basically the application of perpendicular lines. So this point now becomes 8, 0. Height we already had as 6. So 8 units towards right, 4 units towards left. So total distance is going to be 12. So the formula to find out the area of the triangle is 1 by 2 times 12 times 6. And if I cancel this out, 6 times 6 comes out as 36. So that is an approach to solve these kind of questions. Okay. Moving forward now. Okay, radical questions. Most of the students usually make a mistake here of taking the square on both sides. That is the biggest fatal mistake that we can do in these kind of questions. Also, I would like to tell most of you that whenever we take square root of something, it is not two values. It's just a single answer. Like most of you would be shocked if I say root of 25 is equals to just 5. It's not plus minus 5. If someone's saying plus minus 5, that's wrong. Let's try to understand why I'm saying that. When we have an equation, x square equals 25, big roots on both sides, that gives us x equals root of 25, x equals root of negative root of 25. This becomes 5, this becomes -5. So this answer specifically has a 5, not plus minus 5. Positive radicals only give us the positive answers. So if I take the same thing here and I square it, so it will introduce one wrong answer there. It will introduce one negative answer that I don't need. So in these questions, the best approach is to use plugging in. If I plug in the points over here, I'll be easily able to check which was the correct answer. So if I take the first one over here, it becomes 4 plus 1, root of 5 minus 4. So 5 equals root of 1. So hence option A is incorrect. That is a very good strategy when I'm given the options in numerical form. So I can directly use those, put them in one by one. Nobody's asking me for steps here. It's just the answer that matters. So I can directly choose the options and check them. Coming to minus 4, minus 4 plus 1 equals root of 5 minus 4. This becomes minus 3. And if some of you consider this as root of 9 and then take plus minus 3, we'll say this is the correct answer. But that's not, because this is the positive radical. It will only give me the positive answer. It becomes minus 3 equals 3. That is not possible. Hence, option B is also gone. Next. Next, option C, 1. Let's plug in that. 1 plus 1 is 2. When I take a root of 5 minus 1, that's when the positive radical gives us positive answer. 2 equals 2. This one's matching. So C is the answer. That is how options are applicable. We never use completeness. We never use taking the square on both sides. Okay, moving to the next one now. Okay. This question is based on quadratic equations, and this is a kind of question that is asked in module 2 when you get a tough one. It's having all the parameters, no numbers, only words. So in these kind of questions, we study about the properties of quadratic equations, the properties of parabolas. One of them is that if I'm plugging in the value, if I'm having this equation and the parabola is facing downwards, the value A has to be negative. If it's facing upwards, A has to be positive. So first option, I can directly see it's A less than 0. So that is going to be the answer. And I can also see that A is present in all of them. So that is obviously correct. Next, checking the second one and the third one. The third value here is C greater than 0. C value stands for the y-intercept when we're looking at the standard form of a parabola. So I can also observe that my C value is positive, obviously, because it's above the x-axis. So third one should also be there. Now, the very important thing comes now is to analyze what I've got so far and cancel out the options which are definitely not the answers. So I can cancel out A, I can cancel out option B. Because 1 and 3 have to be there. All I need to check now is if 2 is there or not. Checking that is kind of tricky. When we teach quadratic equations, there's an associated formula to figure out the vertex coordinates. Vertex basically means the highest or the lowest point depending on the kind of parabola we have. If I have the stop point as my vertex, its h value, that is the x coordinate, is given by minus b divided by 2a. And we've already seen the value of a is negative. So this negative from here, negative a, they both cancel out the negative values. And this expression as a whole should be positive because this point is placed in the quadrant 1. So both x and y values are positive there. So hence b also has to be positive. So b is also there. So that is how I choose D to be the correct answer. It's having A, B, and C. All of these statements are correct. So that is the kind of analysis we need to do by using the properties of parabola, by learning some basic rules that are covered in the sessions. So that was it from my side. I've covered these questions. Now, if you guys have any questions about this or about SAT Maths or SAT in general, you can type your queries in the chat box. We can take those.
Thank you, Rishabh. If anyone has any questions or doubts, please feel free to drop them in the chat box. We are here to help.
Okay, you can see a query here, Penpa, or sorry if I'm pronouncing the name incorrect. At what grade students have SAT exam? There's no specific grade. They can start giving the SAT exams from grade 9 onwards till grade 12. That is the window in which students can give the SAT exam and as many number of times they want. And whichever score they get, the best one, they can submit their that score for the college applications. How long do I need to study for SAT to score 1400 plus? See, there is no specific number of hours that you need to study. There's no requirement. If there is a certain section in which you're facing and you're having a long list of doubts, it'll obviously require you longer time. If you keep solving the practice sheets that are assigned to you in the classes, you need to keep doing the homework, then regular study of over 2 months to 3 months is required. That's all. Any help for English? Yeah, we're having the English masterclass as well soon. You can type your full name and your and kid's name. I'll get the team assigned for the English masterclass for you. Again, if you want the recording or if you have any such questions, you can put your name and your child's name. I'll ask the team to assign the same things to you. Anyone else having any questions? Okay, so yeah, I've noted down the names. I've taken a screenshot for all these, and I'll ask the team to get in touch with you. They'll send you the recordings, or they can have the discussions there. So, Kanishri, over to you.
All right. So thank you so much for your questions. Well, I would be sharing the link to our newsletter. Please take a moment to save it. Here it is. Also, here is the link to our success stories. We encourage you to go through them when you get the chance. They're truly inspiring. Well, thank you everyone for joining us today. We regularly organize masterclasses and events every weekend, and our team will keep you informed through messages and emails. Also, you can follow our page of Let's Unbound on YouTube. All right. Thank you so much, Rishabh. All right. Please have a good. I hope all of you all have saved the links. Please take care.
Bye.
Bye-bye.